Welcome, everybody, to Demo Days, Decodable Demo Days. Today's demonstration would be about schema validation and schema-on-write. What I'd like to show you is, this is our examples repository, decodable/examples. Today's demo is about opinionated pipelines. What does that mean? Basically, what we mean by that is building data pipelines that won't break, and by doing so, following best practices, right? Putting guardrails around ourselves to make sure that we're in the lane, at least if you recall the picture of the blog that corresponds to this. That protects us and makes us successful at the end, right? With schema validation, you really get to protect the most important stakeholders of your data pipeline, which is the consumers of your data, right? Once you start changing your schema, or if there's something about your schema that's wrong, they're the ones that are going to be affected in their business as well. So here, this document here that I'm showing you, so just to read me for this repository. This is what we're kind of used to. If you use the data lake in a data warehouse, you pull that unstructured data into the data lake, and then you run a bunch of processes to read it and to put it in, give it some structure so that when you write it to a data warehouse or whatever that's consuming that data, it's in a format that it can be understood and consumed. But what we're trying to do here, especially with decodable pipelines, is to enforce schema a little bit earlier in the pipeline, so that most of these downstream consumers won't break, right? It really provides a way to enforce the producers to kind of follow and use best practices, to be interoperable, and by evolving their schemas in the appropriate way, so that downstream consumers don't break. We'll talk about the schema first. It's pretty simple. Then we'll assemble the pipeline, and then we'll look at some issues that, if you try to put these puzzle pieces together that form your pipeline, what happens if they don't match, right? And then we'll view the stream. We'll stand up a good pipeline, and then view the stream and see what it looks like when it's running well. And then we'll also send some invalid messages and see what happens with the pipeline when it errors. Also, what happens when you evolve the schema, right? And we'll get to that in a second. So let's get started. There are some requirements, not too much. I'm using Kafka as the source, right? And you'll need some of this information just to get started. Your decodable account name, a schema. This is kind of a default schema in case you don't have one. You can also create one yourself and pass that to the commands that are following. Bootstrap. This is using Confluent Cloud, and the topic you would want it to read. You want the decodable pipeline to read from. Yeah, let's get started. I'm just gonna execute these commands as we go along. So let's log in first. And this is our schema. It's very, very simple schema. I didn't want to make anything too complicated. There's an employee ID, there's a social security number. You want an ID because you obviously don't want your social security number being passed around as an ID. First name, last name, and an address, and they're all required. So so that's my model, that's my entity, the object that I'd like to save. So I'm going to define it in decodable. So I'm just going to run make stream. All this does is just takes the schema, this schema right here, grabs a bunch like schema information and creates me a stream in decodable. So let's go take a look at that. So this is my account. Go to streams. There's my stream. It has no inputs. It has no outputs. And this is the schema. As you can see, it's the same thing. It's pretty easy, right? Now that we have a a stream defined, let's try to assemble some pipelines together, right? What I want to do here first is create a source that connects to Kafka, a source connector, and start writing data into that employee stream. Okay. So let's try to make a pipeline that's invalid. So let me just run that, and I'll show you the code that actually corresponds to that. Oops. You can see you get this error down here. I'll show you the screen, the command. This is the make file that I'm using to invoke all these commands, and this is the one. This is the target that's trying to create a connection to that Kafka cluster. And if you recall, this is the schema definition that's associated to the Confluent Cloud connector, right? So everything has a schema aside to it. It's what makes those shapes at the end of your puzzles. We're trying to put them together. And in this case, it's not fitting. So this one, I see employee ID is a string. And if I look at the original schema over here, we identified it as an integer. And also over here, if you look at the employee schema, employee ID is an integer. So I was basically prevented from creating that pipeline, right? I was prevented from creating that connection to that stream with that Kafka instance. Okay. So this is what we mean basically by being opinionated. We're not going to let you we're going to do our best to not let you make any mistakes. And schemas really help with that. So let's make a valid connection instead. So all we're going to do is change that string to an integer down here. Okay, so we'll go to our connections. There's a connection that we just created. Let me just quickly activate it so that, because it takes a second for it to start. So as you can see, the schema is the same as the stream that we defined earlier. Details, connection information to Confluent Cloud. And right now, since this is the source connection, it's got one outbound stream. We click that. It takes us to our employee stream that we defined in the beginning. And now it has a reference to that connection, writing data to it. Right now it has no outputs. Let's go back to that connection. Right, so we're going to send some data over this. So it needs to conform to this schema, right? So we activated it. Let's see the status of it. It's still starting up. So let's give it a couple seconds here. We should do this. Let's have a way to preview the data. So let's create a new tab. All this is doing is creating a pipeline. That's that attribute right there. It's doing a select from employee and going to print it out here. So let's just leave this up. Let's check the status of the pipeline. It's still starting. What we'll do now is when that's up and running, we're going to run this command here. I'm going to pass it a JSON. This is a good JSON. This JSON here conforms to the schema up here. Okay, and that's that document right there. Oops. And then after that, we'll see what happens when we send a bad message to. Notice that this isn't the employee ID is a string. First name and last name are spelled out. There are two addresses there. And then we'll see what kind of, this is the error that you expect to see. Let's see if we can go ahead and send it. And so this is actually sending to Kafka. And this is the data that it came through. So that was good. That was a good message, right? So there were no complaints with that. Let's send a bad message over. Gotta wake this guy up and send that over again. So no data is coming out. Send it one more time just in case. No data. So what's happening here? If we view the status, this is the error that we're getting from pipeline. So if we go back to that connector or that connection, it also has that same error. So in the status stopped. So it's the connection basically has stopped the pipeline. You can no longer send really good data to it. It's basically what it's making you do is to do something about it. So you can have a alert of some kind to tell you that this pipeline is down. I could be a producer sending data. I'm monitoring this, and you can immediately see that I'm not getting data here. It forces you to do something about what the data that you get sent over. Is it new data? Is it a new format of that data? So it's trying to protect the consumers downstream of your data. So let's restart this guy. So I'm just going to force a restart of this connector, the connection. And then I'll send over another good message to make sure to see that it's still working. So the preview. Sure, it's always reading from the end. That's right. Activated this. So it's still starting, so you got to wait there for a second. What we'll do is send a good one over, a good message, and then we'll send one that's what we call evolved, right? So what does that evolved message looks like? It's a message that conforms to the previous schema, but it's got an extra field to it, right? Technically, that's still, I've evolved that schema so that's upward compatible. I should be able to still send this data. I think it's running now. Let me just send over the evolved schema. Yeah, so let me actually change the data a little bit. I'm going to make this employee. And then we send that over. Yes, so this is employee 123 as I just changed the ID. Notice that it was able to get all the values, address, employee ID, first name, last name, but only the fields that correspond to the schema or the fields that are inside the schema. If I add additional fields to it, it's just going to ignore it. So this is going to protect your downstream consumers and make a schema evolution more seamless. You could absolutely go in here, add a field, evolve it. I would evolve it from the stream first. And then so on, right? That you'd have to stop your streams, make sure that you have to stop your connections, and then modify your stream to add that additional field, and then modify your connections so they all match, and then start your application again. Okay. There we do have that's basically how we handle errors today. In the future, we'll have like a dead letter queue and have configurable ways of handling error, whether you just allow it to pass through or fail fast and drop into a dead letter queue or something. So stay tuned for that in upcoming demo days. Definitely reach out in our community Slack if you have any questions, and I'll happy to answer them.